Assalamualaikum and good day. Okay, this would be the first part for a new chapter, which is differentiation. Okay, let's look at the first thing in this chapter, and that would be definition of differentiation. Okay, let's say we assume that a function f(x) exists, then the derivative of the function f at x is given by f prime x is equal to limit fx plus h minus fx divided by h when h approaches 0, where h here is delta x, which is equal to x1 or x minus x0. Okay, and this is also called the derivative of f with respect to x. Okay, the same thing, or the first principle of differentiation, the definition of the differentiation. All these three actually refers to this formula. Okay? And then the domain of f prime x consists of all x for which the limit exists. Okay? That's the terms there. And for your information, dy dx is equal to f prime x. This is what you are used to, and also y prime. But let me include that this is also equal to m, which is slope. Okay, slope for a linear function. Okay, so dy dx is equal to f prime x is equal to y prime, and also it is equal to the slope m. Okay, and this is as you can see here, m is the representative of the slope of a line at any point when x equal to a. And next, the equation of a tangent line at point x0, y0 is given by y minus y0 equal to m x minus x0. Okay. For this one, there is another equation that you can use to find a straight line. And that will be y equal to mx plus c. M is the slope. Okay, here, m the slope. And then c is the y-intercept. Okay. Let's look at the first example here. We have, using the definition of differentiation, determine f prime x for fx equal to 5x minus 2x squared plus 7. So, as you can see, the formula here is actually f prime x equal to limit h approaches 0, fx plus h minus fx divided by h. So we have to know what is fx plus h. Fx plus h is, we substitute x plus h in the place of x. Okay, so 5 in bracket x plus h. Remember, all x plus h should first be written in bracket, minus 2 times x plus h squared, okay, plus 7, okay, and then expand. Since this is a polynomial function, so you can expand them all together. Remember, this is just valid for polynomial functions, or I should say one type of function in fx. Okay, so here we have 5x plus 5h minus 2x squared, because I have expand. X plus h squared is x squared plus 2sh plus h squared. Therefore, we have here negative 2x squared, negative 4sh, negative 2h squared plus 7. Next, write fx plus h here altogether, this one, minus fx, this one. Okay, which is 5x minus 2x squared plus 7. And as you can see, 5x divided by 5x minus 5x, and it will be gone. And 5h, there is nothing that we can subtract in fx. Minus 2x squared, minus 2x squared, okay, 0. Minus 4x, okay, minus 2h squared, plus 7 minus 7, it is equal to 0. So what are left are, limit h approaches 0, 5h here, minus 4sh, minus 2h squared, divided by h. Next, factorize h, so that we can cancel the common factor h. Okay, here h, and then we have here 5 minus 4x minus 2 times 0, because we substitute h equal to 0, and hence we have the final answer as 5 minus 4x. Okay, that's the first example, the easiest one in definition of differentiation using polynomial function. Okay, the next one. Okay, we have here Use the first principle of differentiation to find f prime negative 2 for fx equal to 1 minus fx equal to root of 1 minus 4x, and hence find the equation of the tangent line at x equal to negative 2. Okay, the first thing that you need to do is to write your fx plus h. Okay, fx plus h is equal to root of 1 minus 4 in bracket here. Replace x with x plus h. Okay, and then expand. And hence we have root of 1 minus 4x minus 4h. I have my own reason why you need to write fx plus h first and expand it before you determine the f prime x, because it will be much easier this way instead of having brackets, too much brackets in our solutions later on. Okay, and here to determine f prime x, we have limit h approaches 0, fx plus h minus fx divided by h. So fx plus h is this term, root of 1 minus 4x minus 4h, and minus the fx, which is here 1 minus 4x, the earlier one that had been given to us, this one. Okay, and from then divide by h. As you can see, if we substitute h equal to 0, in this part we have 0, 1 root of 1 minus 4x minus root of 1 minus 4x, which it will be equal to 0. And here h equal to 0. So it will be a term of 0 over 0. And this is indeterminate form. That's why we need to multiply with the conjugate. Okay, since this is an indeterminate form, we need to multiply with the conjugate. Please remember, nothing changed inside the radical. We only change the sign for the second term. Okay, since this is minus, it should be plus here. Okay, next expand. Okay, expand, and hence we have this equation. Okay, remember a minus b times a plus b is equal to a squared minus b squared. So here we have 1 minus 4x minus 4h minus in bracket 1 minus 4x. Okay, once again, please remember, anything that we write after the negative sign, minus sign should be written in bracket. Okay, and then since the one that we want to expand is only the numerator, so for the denominator, just rewrite them all together. And remember, this part here should be written in bracket like this. Okay, and then here 1 minus 1 is, okay, all done. Negative 4x, negative 4x, okay, it's gone. So we are left with negative 4h divided by h in bracket this term. Okay, simplify by cancelling the h, the common factor. Remember the basic, multiply with the conjugate, we definitely need to cancel the common factor after that. Okay, and then only you substitute the value of h equal to 0. And then next we have this type of form. Okay, negative 4 over root of negative 4 divided by root of 1 minus 4x minus 0 plus root of 1 minus 4x. And here we have the answer, negative 4 divided by 2 of root of 1 minus 4x, and can be simplified into this. Okay, next, the question, in the question given, we need to find f prime negative 2. Which means just substitute negative 2 in x. Okay, negative 2 root of 1 minus 4 times negative 2, which is here negative 2 divided by root of 1 plus 8 is 9. So we just take the negative answer only, negative 2 over 3. And then if I'm not mistaken, we need to actually, yes, find the equation of the tangent line at x equal to negative 2. So here, let's say if we want to use this function, this formula, 1 minus y naught equal to m x minus x naught. But do we have the value of y? Why not? We don't have it, right? We just have the value of x naught, which is, this one is, m is f prime negative 2 here, negative 2 over 3, x minus minus 2. We have the value here, negative 2. But, can we find the value of y naught actually? Okay, I hope you have the answer. Okay, we can actually find the value of y naught by using this function. Remember, y is equal to fx. So fx equal to root of 1 minus 4x, and therefore here y is equal to root of 1 minus 4 times negative 2. Okay, equal to root of 9, which is equal to 3 here. So here y minus 3. And then rearrange, we have y is equal to negative 2 over 3 x. Negative times negative 2 is positive 2 times negative 2 over 3 is negative 4 over 3. And we rearrange here, it will be plus 3. And then we have the equation y equal to negative 2 over 3x minus 4 plus 9 is plus 5 over 3. Okay, we have actually another method, which is this one. Okay, which means here we use the equation of a line y equal to mx plus c. Okay, for this one, let's say if we use y equal to mx plus c, okay, y is equal to 3, okay, and then equal to m is negative 2 over 3 times x negative 2 plus c. So we need to determine the value of c first, okay. So here we have c is equal to 3 minus 4 over 3, because this one is positive 4 over 3. But when we rearrange it to this side, it will be minus 10, okay. So here we have equal to 5 over 3. And the final answer is therefore y equal to negative 2 over 3x plus 5 over 3. As you can see, we have the same answer for both methods. Okay, it's up to you which one is easier for you. You just have to decide. Okay, and thank you. We'll meet again in the next video. Assalamualaikum.